In the threequel that literally no one asked for, I'll be attempting to make a third and final 18650 battery pack for Xbox One controllers. Why? Because I'm bored and have literally nothing going on. Unlike my last two, which required either hardwiring to the controller or modifying the controller, this one will focus on a less invasive approach, so it can be used on any controller without modification or the need to hardwire it. For this project, I'll be using two balanced 3000 mAh cells in parallel for 6000 mAh, two cell holders, a custom charging and discharging battery circuit, and a donor battery door for an Xbox controller. This is the charge circuit I designed. It consists of a TP4056 IC in combination with a battery protection IC and a transistor, so there's only 3 chips. This is essentially the same exact component setup that you would find on those 18650 charger modules you can get on Amazon or eBay, except I threw in a few things such as more pads for modular hookup and a 5mm LED for when and if I want to use a 5mm LED as opposed to the surface mount LEDs. It's pretty much the same thing, also 2 mounting holes. So let's go ahead and look at the board file. Now it is a bit bigger than those modules, but I feel like that's okay for my purposes, and I am working on a smaller design, which is definitely possible, but this will work for now. So let's go ahead and cue a solder montage. After soldering all the components, we can test it out to see that it charges the batteries. The red LED will turn off and the green LED will turn on, saying that the batteries are fully charged. I decided to mount the 2 cell holders on the back of the battery door in reminiscence of the Xbox 360 controller battery pack to avoid interfering with your fingers during use. I then mounted the board using double-sided tape and soldered some connections. I came up with a spring contact system that will allow for contact to the controller's battery tabs for power transfer. This method keeps it universal so it can be used on other controllers. Now that it's finished, we can test it out by sliding it into 2 different controllers. You'll notice that I added a micro USB port for charging the batteries. I did this so the pack can charge independently without the need to be hooked up to the controller. I did a few current readings and saw that the controller only draws around 60 milliamps when no motors are running. So if we did the math using that 6000 mAh battery capacity divided by 60 milliamp hours of current draw, we would get about 100 hours of runtime, but I think 80 hours is more realistic with the motors. Someone asked me if the 4.2 volts from the batteries will harm the controller since it takes 3 volts normally from 2 AA cells, and I figured this was an important question to answer. In my testing, I found that the controller works normally with a 4.2 volt source. To further this, I even hooked it up to my bench supply and let it run for a few hours, and during this I didn't notice any heat or other issues. Based on that, I think it's fine, but as usual, do it at your own risk. That's it for this video. I hope you had fun. Subscribe for more stuff, and I will see you next time. Thanks for watching.